Welcome to 24 Hours of Pass Summit Preview 2018. We're excited you could join us today for Glenn Berry's session, Sneak Peek Migrating to SQL Server 2017. This 24 Hours of Pass consists of 24 consecutive live webinars delivered by expert speakers from the Pass community. The sessions will be recorded and posted online after the event. You will receive an email letting you know when the recordings are available. My name is Carnegie Johnson. I am a PASS community volunteer and a co-leader of the PASS Application Development Virtual Group. I will be your moderator for this session. I have a few introductory slides before I hand over the stage to our presenter, Glenn. If you require technical assistance, please type your inquiry into the question pane located on the right side of your screen, and someone will assist you. This question pane is also where you may ask any questions throughout the presentation. Feel free to enter your question at any time, and once we get to the Q&A portion of the session, I will read your questions aloud to the presenter. You may be able to zoom in on the presentation content by using the zoom button located on the top of the presentation window. Please note that there will be a short evaluation at the end of the session. Your feedback is very important to us, so please take a moment to complete it. After the webinar ends, the evaluation form will open in a new window in your web browser. Now, I would like to take a moment to thank our presenting sponsor, Quest. The staging of 24 Hours of Pass would not be possible without the generous support of Quest, and they are the reason this event is available free of charge. If you would like to learn more about Quest and sign up for information on how they can help you, please visit the sponsors page of the 24 Hours Pass website. PASS is a global not-for-profit association where data professionals connect, share, and learn. Joining PASS is free and gives you access to hundreds of hours of free online content, live virtual and in-person events, the ability to join local groups in your area, and the opportunity to attend the annual conference PASS Summit. PASS is a great way to connect with like-minded professionals, increase your technical expertise, and grow your career. This 24 Hours of Pass session is presented by Glenn Berry. Glenn is a SQL Server MVP and has a whole collection of Microsoft certifications. His areas of expertise include DMVs, high availability, hardware selection, full text search, and SQL Azure. Glenn is the author of SQL Server Hardware and a co-author for SQL Server MVP Deep Dives Volume 2. As a frequent blogger, Glenn often shares knowledge and insightful tips with our database community. And without further ado, here is Glenn Berry with Sneak Peek Migrating to SQL Server 2017.
Okay, thanks for that introduction. So this is Sneak Peek Migrating to SQL Server 2017. I'm Glenn Berry. I'm a principal consultant at SQLskills.com. Just before I get into the real presentation, I like to brew beer at home. That's my setup. And that's some examples of beer that I've made recently. I've been entering a lot of contests and winning a few medals, so that's my hobby. All right, so our agenda for today: how do you go about making the case for an upgrade to a newer version of SQL Server? Because I've never had anybody come up to me in my career and say, hey, Glenn, would you like to upgrade to a new version of SQL Server? Usually you've got to drive that decision as a database professional. We're going to talk about upgrade planning, all the things you need to do before you go about doing an upgrade with SQL Server. And I'll talk a little bit about hardware and storage. And we'll talk about the different migration methods for doing a production migration. And we'll talk a little bit about some post-migration tasks that you need to do after you migrate in production. So, reasons to upgrade to SQL Server 2017. Well, depending on how old your version of SQL Server is, there's a lot of new features that have been added that aren't in your legacy version of SQL Server. This is especially true once you get up to SQL Server 2016. A lot of features that were formerly Enterprise Edition only are now in Standard Edition. So if you know you're going to be stuck on Standard Edition for budget reasons, a lot of programmability features are now available there. You've also got a higher hardware license limit for Standard Edition and even for Enterprise Edition, depending on what operating system you're running on. And if you're running an old version of SQL Server, it's very likely you're running on old hardware on an old version of the operating system. So using SQL Server 2017 lets you take advantage of new hardware and new features and storage that are not available with older versions of SQL Server. It's also very possible that your legacy version of SQL Server is out of mainstream or even extended support from Microsoft. You get much better manageability support than you had with old versions of SQL Server, and you've got better GDPR support than you have with legacy versions of SQL Server. It also has the benefit of keeping your technical staff happier, which is actually pretty important with the current job market. And so that's another reason to push for an upgrade to SQL Server 2017. Now, making the case for an upgrade, you want to find out, is your version of SQL Server still supported by Microsoft? And there's different levels of support that Microsoft provides. There's mainstream support and extended support. And you can also, with SQL Server 2008 and newer, purchase something called Premium Assurance. If you know you're going to be stuck on an old version, you can't upgrade. But I've got a chart that's going to show you whether or not you're still supported by Microsoft or not. It's also important, excuse me, is your version of the operating system still supported by Microsoft and the mainstream and extended support dates for that. And you want to know, is your version of the operating system on the semi-annual channel, which is not going to be true for most people yet, or the long-term servicing channel? And then finally, is your hardware and or storage out of warranty? And even if it's not out of warranty, it might just be pretty slow, either because it's just old or whoever chose it several years ago just didn't make a good choice. And you might be surprised how much faster new hardware and new storage is compared to what you have now. So here's the SQL Server support end dates. And notice that 2005 is out of extended support and has been for several years. 2008 and 2008 R2 are out of mainstream support. And what that means, by the way, if it's out of mainstream support, there's no more service packs and no more cumulative updates. All you get are critical security fixes. So 2008 and 2008 R2 are out of mainstream support already, and they're going to fall out of extended support early next year, or the middle of next year, I should say. And then SQL Server 2012 is already out of mainstream support, which a lot of people don't realize. And then SQL Server 2014 is going to fall out of mainstream support on July 9th of 2019. So that's kind of the dates. It's kind of handy to have this chart and be aware of this. And some people are thinking about, well, I'm on an old version of SQL Server, so I'm just going to go to 2016. And you can do that, but then you're not going to have as much support as you would get with 2017, and you're missing a few new features that you got in 2017. So having all these dates is pretty handy. So here's the accompanying chart for Windows Server. And hopefully nobody's on Windows Server 2003 or 2003 R2, but even 2008 and 2008 R2 are out of mainstream support. And then Windows Server 2012 and 2012 R2 are also going to fall out of mainstream support later this year. So again, all these facts are helping to build the case to move to a new version of SQL Server, hopefully on a new version of the operating system, hopefully on new hardware and storage. That's the ideal situation. So gathering all this evidence about, oh, we're out of support on the OS and on SQL Server is part of the battle. So what's new in SQL Server 2016 and 2017? Well, I've got a bunch of links here to articles that talk about important new features and new performance improvements that are in 2016 and in 2017. And a lot of people have the idea that 2017 was mainly a Linux port, and that's somewhat true, but there are a few new interesting features and useful features that were added in 2017. And Microsoft has also changed how they service SQL Server with 2017. So there's not going to be any service packs. And all they have are cumulative updates. And what they've been doing in the cumulative updates, which come out every month for the first year, which is also a new thing for 2017, is they add new features, not just fixing defects, but they add new features to the product. So I wrote an article on SQL performance a few months ago that laid out a lot of these things that were added in 2017. So don't just think that 2017 is just a Linux port. If you're getting ready to upgrade, I highly recommend you go to 2017 and not 2016, even though 2016 is a good product. Now, here's an example of a feature that was added in 2016 Service Pack 1. It was actually there before Service Pack 1, but you had to use a trace flag, and it's called Persisted Log Buffer. And what this does is it lets you cache the tail of the transaction log on a second log file that lives on a non-volatile DIMM, which is persistent memory that's backed up by a battery or a big capacitor. And you have to go in and create a direct access volume on one of these NVDIMM devices, and then you create that second log file there. And where this is useful is if you've got the kind of workload that you are seeing lots of log write waits, and you're inserting tens of thousands of rows per second, and that's a bottleneck for you, then using this can get around that bottleneck and eliminate most of the latency that you see in that scenario. And so this is something that you cannot use unless you're on 2016 Service Pack 1 or later, and you have the right hardware. So this is just an example of something that's new that you cannot take advantage of with a legacy version of SQL Server. And I've got the limitations here. It doesn't work with transparent database encryption. It doesn't work on an availability group primary yet. It does work on a secondary, and it doesn't work with virtualization except for the exceptions I have listed below. So probably in SQL Server vNext, it's going to get rid of some of these limitations, is the expectation. So another thing you need to think about when you're planning an upgrade is Enterprise Edition versus Standard Edition. There's a lot of useful features that are still Enterprise Edition only, even after all the things they added in SQL Server 2016 SP1. So probably the number one is online index operations. If you want to have that feature, which is extremely useful to DBAs, you've got to be on Enterprise Edition. Resource Governor is another example. Transparent database encryption, full availability group support instead of just basic availability groups, and then online page and file restore. Those are all examples of Enterprise Edition only features. And the bottom link there is a link to the article that I was mentioning earlier that talks about more reasons to upgrade to SQL Server 2017 instead of just 2016. Now, not only do you have feature differences, you also have performance differences. And Enterprise Edition just performs better because there's some basic differences in the code path between Enterprise Edition and Standard Edition. So Enterprise Edition uses parallelism for a lot of things that you do, like building indexes, for example, and running certain kinds of queries. It also gives you better storage performance. It's much more aggressive about doing read-ahead reads, for example. It does something called merry-go-round reads also. And it uses column store indexes and in-memory OLTP without being limited to a certain number of cores or a certain amount of memory like Standard Edition is. And it uses aggregate pushdown and local aggregates when it's running certain kinds of column store queries, and it leverages your processor hardware to run certain kinds of column store queries. So I've got another article that I wrote that explains some of this in more detail with some examples. So the point here is you could start off on Standard Edition and do an Edition upgrade to Enterprise Edition and get a nice performance benefit without making any changes whatsoever to your code. So that's another reason to argue to try to upgrade to Enterprise Edition if at all possible. Now, SQL Server 2017 has a certain licensing cost associated with it, and luckily they didn't increase the prices over 2016. So you can either go Standard Edition with the server license and have CALs, but not too many people have that luxury because they have too many users. So most cases you're going to be do core-based licensing. And you can see that Enterprise Edition is roughly 4 times more expensive than Standard Edition. And there's certain caveats associated with the licensing too. So you have to have a minimum of 4 core licenses per physical processor and 4 core licenses for virtual machine unless you have licensed the entire host and you have software assurance on top of that. And so this comes into play because licensing costs for SQL Server very frequently far outweigh your hardware and storage costs. So it's very important that you think about this and don't just let your server admin pick your hardware and end up paying a lot more than you need to for your SQL Server licenses. Now you've got some license limits associated with SQL Server. Now Enterprise Edition can use whatever the operating system lets you use. and it makes a lot of difference what OS you're on. So Windows Server 2016 is where you want to be right now, and you can use up to 24 terabytes of memory there. If you're still on Windows Server 2012 R2, that's only 4 terabytes, and that can be an issue for a lot of people, even on commodity hardware. And then with Enterprise Edition, you can use the OS Max for sockets and physical cores. So it's, good situation on Enterprise Edition. But Standard Edition has issues here. And you need to be very careful about this and when you're planning, because you're only allowed to use 128 gigs of RAM for the database engine per instance. Now you've got some additions to that if you're using in-memory OLTP or column store indexes, but that's the basic limit. So you don't want to go and buy a machine with a terabyte of RAM if you know you're going to run Standard Edition unless you're going to install multiple named instances. But where most people run into this is with the socket and core limits. So you're limited to the lesser of 4 sockets or 24 physical cores, or the lesser of 4 sockets of 24 virtual cores if you're virtualized. And if you install SQL Server Standard Edition on a machine with more than 4 sockets or more than 24 cores, and this quite often comes into play on VMs, it's only going to use the first 4 sockets and the first 24 cores. And if those happen to not be balanced across your NUMA nodes, you'll have an unbalanced situation by default. And so make sure you don't make that mistake. And these license limits haven't changed since SQL Server 2016 SP1, by the way. All right, another thing that people don't seem to always be aware of is that Windows Server 2016 moved to core-based licensing. And this can cause problems, not because it's very expensive, but because it might cause your server administrator to make a bad decision because of this fact. Because it requires a minimum of 8 core licenses per processor or 16 core licenses for the entire server. That's the minimum. And because of that, your server admin might decide to buy a server with a minimum of 8 core licenses, or 8 cores rather, even though you might not need that much for your workload. And the cost of operating system licenses for Standard Edition is pretty trivial. 16 core licenses are only $882. And all you need, by the way, is Standard Edition for most scenarios. There's no real functionality difference with Data Center Edition, except you get more virtualization rights and you get the storage space as a direct feature, which you don't need typically unless you're running hyperconverged on the instance where your SQL Server is installed. So the point here is make sure you understand this and make sure that this fact doesn't drive your server admin to buy more cores than you need for SQL Server, because the SQL Server licenses are a lot more expensive than the OS licenses. All right, so SQL Server and hardware selection. Nobody's ever come to me and said, hey, the database server's too fast. Have you ever heard that? But you're going to be blamed for bad performance and have to deal with it on a day-to-day basis if somebody makes a really bad choice on your hardware selection. And new server hardware is very, very affordable compared to SQL Server Enterprise Edition licenses. And so because of that, you don't want to make the common mistake of reusing your old database server hardware from 2, 3, 4 years ago for your brand new version of SQL Server. And again, you want to keep in mind those SQL Server hardware licensing limits that I mentioned earlier, and they're different for different versions and different editions of SQL Server. And then finally, don't be afraid to point out the age and performance of your current hardware, because it could be, depending on who chose it, that it's significantly slower than what you can get right now. And don't be shy about pointing that out. So here's a real quick little chart about the Intel server processor family tree. And the reason I point this out is this helps you figure out how old your hardware is and how many generations behind you are where the current state of the art is. And the latest and greatest for Intel server processors is the Skylake SP. And they changed their naming scheme there. So instead of Xeon E5 and Xeon E7s, they have Xeon Platinum and Xeon Gold and Xeon Silver, for example. So it's a little bit confusing there. But these were introduced in the third quarter of last year, and they're getting ready to introduce the next generation sometime later this year. It's going to be Cascade Lake SP, which will be socket compatible with the current stuff. So current model servers will work with the new processors. So this is a little bit dense here, but what this is explaining is that Intel puts out a document every time a new generation of processors come out. They have about a 5 or 6 page summary of all the new features. And this is particularly important if you're a virtualization shop, because let's say you're running back on a Sandy Bridge processor and you're getting ready to upgrade and make the case for an upgrade. Well, you can read through these little documents and pick out, okay, here's this new feature they added for virtualization in Haswell, and here's another feature they added in Broadwell. And you can use that to help build a case. Okay, we virtualize everything, and if we had new virtualization hosts with all these new features that help virtualization performance, that would really benefit us. And that's what all these links are about. So these are all a bunch of PDFs that you can download and use to help justify your upgrade process. All right, so after you've gone through and kind of done that and get an idea of how old your current hardware is and what's currently available, how do you actually choose? Because, for example, Intel Skylake has about 50 different processor models. So how do you choose the exact processor? So what I like to do when I'm doing this for clients is go through and use actual TPCE benchmark scores. And these get submitted by the server vendors like Lenovo, for example, and they submit the flagship processor for that generation, the one that has the most cores. And usually that's not what you want for SQL Server because it's so expensive to license. And so what I do is find the actual submission for that generation and then adjust it for the core count and base clock speed difference to the processor I'm actually thinking about. So instead of the top of the line 28 core processor, I do this calculation and figure out the score for an 8 core processor that I actually want to use for my workload. And once you've gone through and done this, the total score that you get is the CPU capacity of the system. That's basically how many concurrent queries can you run at the same time. And then if you divide that by the number of cores in the system, that gives you a measure of the single-threaded performance of that processor, which is really important. You want the highest single-threaded performance possible because then you're maximizing how much performance and scalability you get for each one of your expensive core licenses. So doing this, which is not very difficult, is really useful when you're trying to make a calculation for upgrades or consolidation or virtualization. Instead of just guessing, you've got something to base your numbers on. So I've already done the math for you on a couple of the slides that are coming up here. So this slide shows you all the current Skylake SP processors. And these are the best processors at each given core count. So Platinum 8180 is the top of the line flagship processor. And these numbers are for a 2-socket system with 2 processors populated. So the raw score is the capacity of the system. And then the total cores is how many cores are in this system, physical cores. And then the score per core is a measure of the single-threaded performance. And then the far right column is how much the SQL Server licenses would cost for this 1 2-socket system. And you can go through and see as you go down the chart, your capacity goes down, which you would expect, and your license cost also goes down, but also your single-threaded performance tends to go up. So what's happening is the lower core count processors run at higher clock speeds and they have more L3 cache to spread out across fewer cores, and they run faster. There's a definite advantage there. And so you can use this to kind of pick out a sweet spot and also point out certain ones you want to avoid. So like the Platinum 8170, for example, is a really bad choice. It has a very low base clock speed. And if you were thinking about getting that one, you'd be better off to get the Platinum 8168 that has fewer cores and actually more capacity. And you would save a huge amount of money on your license cost. So again, if you see your server admin getting ready to buy an 8170, try to talk them out of it and say, don't do that. Get a Platinum 8168 instead. So this is the chart for Skylake. And then here's the same chart for Broadwell, the previous generation. And again, the high core count processors are at the top, and then going down, you get into the lower core count processors, and the green choices are particularly good, and the red ones are particularly bad. And for some reason, I don't know why, but I've been seeing a lot of clients in the last few months who had bought the E5 2640 V4, which is a really, really bad choice. But that seems to be very popular for virtualization hosts. So that's a bad processor compared to the other ones from the same generation. So, when I do my full session at PASS, I'll go into a lot more detail about this and show you the math of how you get these numbers. But these are the takeaway numbers for you right now. So here's an extreme example of a really bad choice versus a very good choice for this same exact new server. So imagine you're getting ready to go out and you're going to buy a brand new Dell R740 server. And one thing you could do if you didn't know any better is you would go out and get two processors that were the Xeon Bronze 3106. Or you could get just one processor in that two-socket server, but pick the Xeon Gold 6144. And of course, if you did that, you would have only half the memory capacity, so keep that in mind. But beyond that, you would get almost double, in fact, a little bit more than double the capacity. And you would get roughly 4 times better single-threaded performance, and you would have only half the SQL Server license cost. So saving $57,000 on your license costs would buy 3 or 4 of these servers at least. That's how much money you'd be wasting. And so again, hopefully nobody makes this bad of a choice, but this is an example of how bad of a choice you could possibly make. All right, real quickly, flash storage. A lot of people seem to have the idea that all flash storage is the same, and people will say, well, I've got an all flash array. I've got all flash storage. But all flash storage is not the same. And the main thing to look at the top when you're looking at flash storage is what interface and what protocol is your storage using. So older flash storage uses the legacy SAS or SATA interface, and it uses the legacy Advanced Host Controller Interface or AHCI. And with SAS and SATA, it could be 3 gigabits per second or 6 gigabits per second or even 12 gigabits per second. And that gives you certain limits for how much sequential throughput you get out of a single device. And the AHCO protocol was designed for magnetic hard drives, and it really doesn't perform that great for solid state storage. But that's what a lot of flash devices have. They have that old protocol and that old interface. And where you want to be with flash storage is using PCI Express. And that uses either a slot on their motherboard, or with some newer servers, you've got new form factors such as the ruler form factor, or just a drive bay in the front where you can plug this in and still be on a PCIe bus. So this gives you a lot more throughput and much lower latency. And it makes a big difference of what version of PCIe we're talking about here. Currently, the greatest is 3.0, but 4.0 and 5.0 are coming in the next 12 to 24 months. And it's also really important to have the new protocol. It's not that new anymore, but non-volatile memory express, NVMe. This gives you much lower latency and much lower CPU utilization on the host than the older protocol. So that's the kind of storage you want for flash. And even within those different protocols and interfaces, you need to think about what kind of NAND you have for your flash storage and what kind of workload it's set up for. Is it more for read-only or read-heavy workloads, or is it for mixed use, or is it for write-heavy workloads? And that's going to have an effect on its durability and its performance for different kinds of workloads. So the main takeaway here is don't think that all flash storage is the same. There's huge differences between these different kinds of flash storage. All right, so just to review the hardware and storage real quickly, processor selection is critically important because it's going to drive your other hardware and storage choices. It has a huge effect on your performance and your scalability, and most importantly, your license cost. And modern Intel processors are usually the best choice because they have better single thread performance, but AMD has the EPYC 7000 series, and they're going to introduce the second generation of that later this year. And this has a lot of I/O capacity and a lot of memory density. And these work really well as single socket servers for certain kinds of workloads. And all the major server vendors have AMD-based servers that use these processors now. So give those a look. Don't just think, well, I have to get Intel. And then think about your workload type as you choose your hardware, because different workload types are going to benefit from other certain choices on the storage and CPU selection front. And then make sure you know up front when you're planning, am I going to be on standard edition or enterprise edition? Because that's going to have a big effect on what you choose to do here. All right, so migration planning. What you're trying to do with migration planning is avoiding any data loss during the migration effort. And that's going to drive what migration method you might want to use. And you're also trying to minimize your downtime during the production migration. What are the business requirements? Some people have it very easy. They can just take all weekend to migrate. And some people, every second of downtime is a big deal. So that's going to have an effect on what migration method you use. And also, you want to try to, if possible, minimize the infrastructure impact on your network and your storage during your migration effort. So going through and doing some work and getting everything ready to go to migrate really helps. And then finally, you want to avoid performance regressions. You don't want to be unpleasantly surprised by, hey, we just went out and bought a new server and we're running a new version of the OS in SQL Server and performance is worse than it was on our legacy hardware. We don't want that to happen. And it's fairly common, unfortunately, to get performance regressions if you don't do any testing. You just migrate or upgrade in place on your current hardware. Don't do that. All right, so some of the things you want to do is you want to go through and do some work and get your legacy databases ready to migrate. And the objective here is to reduce the size of the databases to make it easier to migrate them. And also, you just want to clean up a lot of the garbage that collects in your databases over time, if possible. So pretty much every database I've ever looked at has a bunch of scratch tables where somebody did a select into another table and there's a date on the end of it. It's kind of a giveaway. And so you'll find tables from years ago that nobody ever uses anymore. So go through and try to clean those up if you can. And then make the effort and talk to the business and say, hey, wait a minute, do we need to have, history data or click data from 5 or 10 years ago in here? And if you see stuff that looks like it's not very useful in log tables or archive tables, try to see if you can delete it. And if you can't delete it, see if you can move it to an archive table or maybe to an archive database, or at the very least, go through and use data compression on it to try to reduce the space you're using. And you're also looking for any unused or duplicate indexes that you can try to get rid of. And finally, go in and actually do some index maintenance. Even if you are one of those people that doesn't believe in index maintenance, this is a good time to do it. And then if you have cleared up a whole lot of space in your data files, you might want to actually shrink them. Shrinking a data file is usually a bad idea because it's very resource intensive and severely fragments your indexes. But if you've cleared out many hundreds of gigabytes or terabytes of data from doing all this cleanup work, doing a one-time shrink and then going and reorganizing your indexes to eliminate the fragmentation might be worthwhile. You also want to take the time to reduce your VLF counts, which also means shrinking your transaction log file. And if you've got any extra transaction log files that were there because you had an emergency from a runaway transaction log, now's a good time to clean those up and get rid of them. And then finally, make sure you run dbcc check db before the migration. And if you run into any issues, get those cleaned up. So you're just trying to get your old databases ready to go for the migration. So production migration methods. The main methods that people typically use is a backup restore sequence or using the new Microsoft Database Migration Assistant tool. Using log shipping was probably my favorite method right now. And then using database mirroring. Those are all very viable methods that are very useful for migration. And then there's some things you need to do after you migrate and come up on the new instance. All right, so backup and restore. What you're doing here is you're going through and doing a full backup of your legacy database and then restoring with no recovery on the new instance. And of course, I should back up for a second. What you hopefully have done, if you have a new server, is you've gone in and set it up and configured it, and then you've gone in and done a backup restore sequence on it, and you've gone in and done all your functional testing and done your load testing and performance testing. And you've done all that for as long as you need to make sure you're confident that everything works great in the new environment. So after you've done all that, now you're getting ready to do your production migration. So you get rid of all those old backups and you're going to go through and actually move the live data from your current environment to your new environment. So backup restore database is one way to do it. And it's a lot less risky than attach and detach, which some people like to do. So I really don't recommend that you attach, detach. Instead, go through and do backup restore. And depending on how you do this, this could require a long outage if you have a really large database. But if you're smart about it, what you do is you do a full backup, restore that with no recovery, and then if necessary, do a differential backup and restore that with no recovery. And then if necessary, do multiple log backups and restore those with no recovery. And you can continue to do that for as long as you need to until it's time to do your final failover. And you can script this out to make it somewhat automated. And again, you want to make sure you've done the work on your legacy databases to reduce your backup and restore times. And you want to take advantage of things like backup compression and using the backup tuning commands. That can actually make a huge difference. And things like striped backups can make a big difference in how long it takes to back up and restore even a very large database. And making sure that instant file initialization is enabled on the new instance is important, and having the transaction log small is important because it can't use instant file initialization. That only works on data files. So that's some of the things you want to think about with backup and restore. Now, another thing you can do is the new tool, Microsoft Data Migration Assistant. And this replaced the old database upgrade advisor, and it has two uses. First of all, you can use it during the testing and planning process to spot deprecated features and breaking features, and it'll recommend new features that you might be able to use on the new version of SQL Server. Although I have to tell you that it's heavily, heavily biased towards Azure SQL Database. So it really wants you to try to use things like stretch tables, which is a good idea, but economically doesn't make sense for most people, unfortunately. So you can do that first during the planning process, but then let's say that instead of just 5 databases, you've got 500 databases that you need to migrate. Well, the data migration assistant will let you go through and migrate hundreds of databases all in one batch. So that's kind of handy. Or if you are actually getting ready to migrate up into Azure, you can use the data migration assistant to do that. And you can use it to move just your schema or your entire database. So depending what you're trying to do, it's a pretty handy tool. So that's another alternative for your production migration. Now, another method that I really like is using log shipping. And log shipping is very easy to configure and use. It doesn't require the servers to be in the same domain. They don't even have to be in a domain. It doesn't require certificates like you might have to use a database mirroring. You don't have to go in and configure endpoints. And it doesn't put any extra load on the legacy instance. So you can go in and set up log shipping and then be running log shipping for as long as you need to before it's migration day or migration night. And if you're in full recovery already, all you're doing is taking log backups and then copying them and restoring them on the new server. And that can all be running with the agent jobs that are built into log shipping out of the box. And you can run that way for quite some time. And then when it's finally time to fail over, it's pretty short downtime because you just run the final log backup jobs on the old instance and then copy those files to the new instance and then restore them and then restore each database with recovery on the new instance. And you can script all this out ahead of time and then point into applications at the new instance. And this can be done in a few minutes if you get it timed out and scripted out correctly. So again, T-SQL scripts are your friend here. It really helps out with this. And then database mirroring is another alternative. Database mirroring is a little bit more complicated to set up, but I've done it so many times over the years where you migrate from an old version of SQL Server to a new version of SQL Server using database mirroring. And when you're setting up mirroring for this purpose, you don't need or even want a witness instance because you don't want any possibility of an unplanned automatic failover, because the failover is a one-way, one-time trip from the old version to the new version. And so you go through and do all the prep work in advance. You create the mirrored copy of your databases in advance, and the users have no idea what you're doing. So however long this takes you, you're doing the work, and you do have to create the endpoints and make sure you've got firewall access for them. And this is a lot easier to do if your servers are in the same domain. If they're not in the same domain, you're going to go through and use certificates, which is a lot more difficult. And this does add a little bit of extra load on the legacy instance because all the write activity has to be picked up and sent over the network and then replayed on the other side. So what you want to do if you're running Enterprise Edition is make sure you're doing asynchronous mirroring for this until you're ready to fail over. If you're on Standard Edition, you don't have that luxury. You're going to have to use synchronous mirroring for this. And then when it's time to finally fail over, it's just a property change and a failover, which typically takes just a few seconds, 15, 20 seconds or less in most cases. It's just a property change and then process the redo queue on the new instance. And again, you can script this all out in advance so you can fail over a whole bunch of databases very quickly and come up on the new instance. And then you go and break the mirror and recover the database on the other side and then make sure nobody can connect to it accidentally. But this works very well. It's just a little bit more work up front, but it makes your failover more quickly at the end. All right, another feature you should take advantage of as part of this, the migration effort, is called persisting the statistics sampling rate. And this is a new feature they added in 2016 SP1 CU4. So you can go in and add a new keyword called persist sample percent equals on. And that way, if you want to make sure to do a full scan of particular indexes, you can make sure that it does that, even if it's an automatic statistics update in the future. So that's really pretty good that they added that. And it works with create statistics and with update statistics. And so this gives you a lot more flexibility, and you should definitely take advantage of this after you move to 2016 or newer. So this is something you would do after you failed over. And then post-migration tasks. So this is after you do the failover and you're running on the new instance. So things you need to do, first of all, run a full database backup on the new instance, on the new version of SQL Server. And you want to get all the user databases and all the system databases. So start your backup sequence on the new server. And then go ahead and run dbcc checkdb on all the user and system databases. And then somewhere along in this sequence, update your statistics. So what I always do, just as a very first thing, is run sp update stats, and then go through and do update statistics with a full scan later on the ones that are more important. And then what you actually want to do when you have time is rebuild all your indexes, because even though you've updated statistics, sometimes rebuilding the indexes is actually very helpful. And this is straight from Connor Cunningham, that they recommend that you do this when you go to a new version of SQL Server. Everybody used to think it was just statistics that need to be updated, but rebuilding them is actually useful for the query optimizer. And then go in and enable Query Store. Query Store is a very useful feature that was added in 2016 that for some reason, a lot of DBAs are not using, either because they don't know about it or they're afraid of it. They've heard bad things about it, but it's very, very useful for spotting and correcting plan stability issue problems or parameter sniffing problems. And it's very useful. And not only do you get Query Store in 2016 and newer, but if you're running 2017, you can use automatic plan correction, which is built on top of Query Store, to automatically spot performance regressions based on CPU utilization for queries and just fix it automatically. So it automates something you have to do manually in 2016. Now that's only available in Enterprise Edition, automatic plan correction, but it's another reason to work towards 2017. And it's another reason to use Query Store. And then, depending on what you did with your testing, you might want to change your compatibility level on your user databases. In fact, in most cases, you probably will, but you might want to be using the legacy cardinality estimator, which you can set at the database level with database scope configuration options. So you can, for each database, you can pick which cardinality estimator you use, and you need to make sure you test this both ways before to make sure what's going to happen with the different cardinality estimators when you move to SQL Server 2016 or actually 2014 or newer. This is the one place where I've seen many people run into issues where they didn't test and they just blindly started using the new cardinality estimator, and they find certain queries that have terrible performance regressions. And there's lots of ways to work around this. My former colleague Joe Sack wrote a really good white paper in the 2014 timeframe that explains all the principles behind this and some things you can do to mitigate these regressions. And with 2016 and newer, you've got more options to handle this. And then finally, you just want to start monitoring your instance health and performance and doing whatever additional tuning you might have to do that wasn't uncovered during the testing. But hopefully, if you've done a good job of your testing, you're not surprised by any bad performance and everything's running great and you have a very calm day after you migrate. That's the objective of doing all this planning and picking the right hardware and picking the right storage and making sure everything is configured properly. So, I have so much more time during the actual PASS Summit. I have a half-day session to get into a lot more detail and have demos on a lot of this stuff than I have during this preview session. So now we've got some time for questions.
Okay, great presentation, Glenn. We've got a couple of questions in the question queue. I'll start with the first question here from Brian. Brian asked for the TPC-E scores, could you do a metric of license cost to score ratio?
Oh yeah, you could definitely do that. I mean, what I have is something we call the magic spreadsheet, where I've got every single processor that Intel has made for the last 10 years. And I've got all those numbers in there, so I could easily add a column for that. And of course, I don't give that spreadsheet out, but I show you how to make it yourself. So you could easily do that calculation yourself to kind of find a sweet spot for licensing costs.
Okay, great. Dirk asked, if all SQL servers are virtualized, which CPU should you choose, given good versus best, or optimized, more optimized for virtualization, or what's the sweet spot?
Yeah, that's a good question because your virtualization admins, they typically like to have high core count processors and as much memory as possible so they can have more VMs on the same host. And that's great for web servers and file servers, but it's not the best solution for SQL Server performance. So what I always try to do, I don't always win, but I try to convince them, hey, if this is going to be a dedicated SQL Server virtualization host, how about if we pick this lower core count processor? And you don't have to get a 4-core processor or a 6-core, but for example, there's an 18-core that performs pretty well in the current generation of Intel. So I try to sell them on that as opposed to the 28 core if possible. And that doesn't always work, but that's what I try to do if performance is important. I mean, maybe you've got some line of business SQL applications where performance is not that big of a deal, but on your more mission critical ones, try to have them on a faster virtualization host if you can.
Okay. And Bill asked, does Standard Edition now support all the compression and other options that Enterprise had in the past?
Yes, it does, but you're not going to be able to do things in parallel. So like building an index is not multi-threaded. So there's some limitations there. And of course, you don't have online index operations. So if you do data compression, you have to rebuild it. And that's going to be offline in Standard Edition, where it's online in Enterprise Edition.
Okay. Charles has a question regarding the data migration assistant, and he's asking, is there any recommended method to perform the kind of pre-migration analysis that was done previously with the trace flag for deprecated SQL commands?
Well, you can still run that query using that trace flag to try to find things, but all you can really do is run the data migration assistant, and I think it has a command line interface if you want to try to automate it, but run that against your databases, and you can run it against multiple databases at the same time if you want to, and it'll find a lot of issues. It's a pretty decent tool, and they keep improving it, putting out new releases every month or two.
Okay. Frank asked how the cloud and database as a software affects your recommendations. I guess dealing with Azure. How would this impact your recommendations?
Well, I mean, if you're talking about Azure SQL Database, that's platform as a service, and you really don't have any visibility to what's going on with the hardware and storage. You know, you're just talking about databases, but infrastructure as a service, so Azure VMs, you can go in and look and see what kind of hardware is underneath that. And you can also use these calculations to help you figure out how big of an Azure VM do I need? What level of service do I need? You've also got Azure managed instances that come into play. So going through and doing a lot of this work is also still useful, but some of it changes a little bit in the cloud.
Okay. Okay. And Anaswamy asks how to take care of features like CDC, auditing, PBM, extended events. I guess how would you handle those in your migrations?
Well, I mean, mainly what I talked about today, excuse me, it's just, basic database engine features where you're moving a database from one place to another. But most of that stuff is just built into the product. I mean, you're going to get better support, and not too often do you find breaking changes related to those. So, yeah, I'm not sure if I really answered that question, but I mean, the main things that come up that are more tricky are things like replication and things like availability groups and how do you migrate those. And I didn't talk about that today at all, but
Okay. All right. And we've got several questions. You may want to take some of these offline. But yeah, people are really engaged. So we'll continue here with we've got a few more minutes left and we'll continue with
that's fine.
what we have. So Ian asked, how does it handle, or how does SQL Server 2017 handle always on databases during upgrades? Will the availability group be upgraded or just rebuild it?
Well, there's ways if you really want to do it to add to not have to rebuild everything where you add a new node as part of your topology and then do some failovers. That's one way of doing it. But what a lot of people will do is they'll just rebuild the availability group in the new environment. So it kind of depends on how strict your SLAs are and how much work you're willing to do. But there's ways of doing it, either with rebuilding everything or by selective failovers and not having to rebuild everything all at once.
Okay. Pablo has a question regarding memory requirements for migration. Are you finding a need for increasing RAM?
Not necessarily. I mean, one thing that happens over time is that the size of the executables and the DLLs for SQL Server is increased. And so you might want to have a little bit more memory than you had in the past. And this also affects how well things run. So if you try to run a new version of SQL Server on a much older processor family, sometimes you'll have problems because the caches weren't as big. But beyond that, I usually base memory on the workload, and how it's running. So I don't usually just say, well, I'm going to add more memory because it's a newer version. That's not necessarily how I look at it.
Okay, so we've got time for maybe a couple more questions here. Ed asked, what is the best practice to migrate SQL Server logins and database users?
Well, there's an SSIS task that you can use to do that with. The data migration assistant will do some of that for you. What a lot of people will do, they'll just script things out and create the users with the same SID. If there's SQL Server logins on the other instance, that's where you really get bit if you don't do that properly and you get orphaned users. But there's multiple ways of doing that depending on how many we're talking about and whether it's just a few that you can easily script out or you've got, thousands that you have to deal with.
Okay. And our final question we'll take for this live session, but these questions will be forwarded to our presenter. And how do you want to follow up with these, Glenn?
Well, anybody who didn't get their question answered, send me an email, glenn@sqlskills.com, and I'll try to answer it for you. So,
Okay. So the lucky winner here for our last question is Ronaldo. He asked about the use of GPUs when selecting his CPU.
well, that's an interesting question. As far as I know, SQL Server is not using GPUs. That's something that I've brought up with the development team to try to get them to look at that. And I think they have looked at it preliminarily and they didn't find a huge benefit back in the 2016, 2017 timeframe. But that could change in the future, and that's something a lot of virtualization stuff in the cloud is taking advantage of now. So yeah, that's a good question.
All right. Well, that's all the time we have for questions in our live session, but please follow up with Glenn at his email. And if we can move to the next slide. So stay tuned for our next session, Why Performance Tuning Wisdom Needs Expiration Dates with Brent Ozar and Eric Darling. I'm looking forward to that session as well. So I will join you guys there. Thank you everyone for attending and have a great day.
All right, thanks everybody.